This brings us to the second derivative test. So again, in addition to testing for concavity, which is what we've been doing with the second derivative, we can use it to perform a test to also determine relative min and relative max. And again, it's based on the fact that if I have something that is concave up, the cup, then if I have a critical value on there, then obviously it's a minimum because that's the only thing I could have on something that's concave up. And if I have a function that's concave down and I have a critical value that's in that function that's concave down, this guy must be a maximum. So again, this is going to help us. That's the second derivative test. So both of our tests determine min or max, but they do it using a different function, either the first or second derivative. So again, here's the official definition. If f double prime of c is greater than 0 or positive, then f has a relative minimum, because again, if it's positive, it's concave up, which means a minimum, and if it's negative, it's concave down, which means a maximum. If f double prime of c is equal to 0, the test fails. That means we don't know what's there. In that case, we have to use the first derivative test. So let's take a look at an example using the second derivative test. First thing I need to do is find the critical numbers. So this is a step above and beyond what we've done on our last ones. Why do I need to find the critical numbers? Because I need to find where those guys will be in the interval, in which interval it will be in, so that I can determine if I have a min or a max. So let's do that. First thing I would do is, of course, find the first derivative. First derivative, pretty straightforward to find. Set that equal to 0 and find the critical values. So again, that's just algebra. I'm not going to spend a ton of time on that. So I have 3 critical values. Then what I'm going to do is I'm going to find the second derivative, which again, this is a polynomial, so it's pretty straightforward. Here's my second derivative. And notice here, I'm not creating intervals. I'm just plugging them in to the second derivative. So I'm taking my points of -1, 0, and 1, and I'm plugging them into the second derivative to determine if it's a min, max, or if the test fails. And notice I've given you one of everything here. So this guy was positive, so I got a min, because remember, positive means concave up, so there's a minimum. This guy was negative, so that's concave down, which means I have a relative maximum. This guy was 0, which means the test fails. So now I have to keep working at 0. Since the second derivative test failed at 0, we can check using the first derivative test. So let's remember how I did that. Here I would go from -1 to 0, and from 0 to 1. And again, I used 0 as that point because that was the point I wasn't sure. And the first derivative test is going to tell me if it goes from increasing to decreasing, it's a max, and decreasing to increasing, it's a min. But if you'll notice, what happened here is I went from increasing to increasing, which means it is neither a min nor a max since it's increasing on either side. So it's one of those that increases, levels out, and then increases again. So here's my conclusion using the second derivative test and then also the first derivative to help me out at x equals 0. Again, don't hesitate to check your work against the actual graph of the function. I've graphed the original function. I had found the point -1, -2 was a minimum, and that is certainly shown in my graph. 1, 2 was a maximum, again shown in my graph. And then 0, 0 did exactly what I said it was going to do. It increased, evened out, increased again. So we can always back it up based on the graph of our function. So this is a handout that sort of summarizes what we've learned from 3.1 to 3.4, I guess with the exception of 3.2, which is mean value theorem and Raleigh's theorem. This is a great review and a great handout. Some people really love this table and some people are like, I don't even know how to read this table, so then just don't use it. Essentially, I've given you different strategies for finding the relative min or max based on the first derivative, the second derivative, or the original function. to determine intervals of increasing or decreasing, to determine points of inflection, and determine intervals of concavity. So again, print this out if you'd like, have it handy when you take your major quiz over 3134.